So the whole subject, data as a product, data mesh and MACH, is something which is so, I wouldn't say convoluted, but it's coming up so regularly that I was really very insisting that we do these sessions. And when we see the feedback so far, as well as comments from folks, it is obviously a good subject. But what do we really want to do? Where's the part coming from? When we take a look, I love to talk about my 4Ds of transformation, and I'm running around with this slide for quite a while. The interesting part is people talk often about the digital DNA of modern companies, which sounds really great, but we have to start at the left side. In a lot of industries, there's still a lot of paper. When you go into supermarkets, you still see people running around many times with paper lists and checking the shelves and checking what's happening. Fully digital, fully digitalized processes are still coming and are not across all industries available. And then when you say, okay, I'm digital now, what means now a digital transformation? Hey, I am digital. How do I transform myself? I'm not a transformer, right? I like Bumblebee. Then it's really by turning existing processes into something completely new, which is not only lifting the digitized process to a digital process, but to something which is way more practical and different to be utilized than what people can do today. Now, that obviously leads to the digitally transformed enterprise, which, interestingly enough, when you talk to people is, oh yeah, we are completely digital. But when you ask also, you have no legacy monoliths anymore, and your software is completely modern, and then you get, I wouldn't go that far, but we're digital. So really, if you want to be a digitally transformed enterprise, you cannot afford to have digital monolith, or you have to have a plan how to get rid of it sooner than later. The more important part is, and we saw this over the last 2 years a lot, is that you're able to turn on a dime. You move around very quickly. We saw banks who replaced their paper process, digitized their processes for mortgage onboarding, which was in some countries you have like this high piles of paper still to fill out to get a mortgage, and then afterwards closing houses, into a complete digital process because the branches were simply shut down. Or you look at retailers which were shut down. So not the retailers necessarily for food, but anybody else. So how can you still make business? And you saw a lot of pick and click technology popping up out of nowhere, which was amazing. And people really enjoyed that and liked that. Better actually than shipping at home. And what you want to do then, you have data. You want to unlock the value of this new data, which is basically the legacy monoliths are preventing literally the unlocking often. And vendor locking is a big subject. Yes, you want to have the capabilities to choose and pick. Everybody needs to have choices. And if you're stuck on one way and that vendor is not optimizing anymore, you want to have a choice to move. If that vendor is not innovating, you want to have a choice to move. And the worst example is, and I bring this up and people kill me over that one, when I say Oracle's core database is not any more innovated since 1988. And then people completely slam me. But if you think about it, yes, they brought in XML. Yeah, this is just pretty much blobbing it. Oh, JSON, just blobbing it. Yeah, we have some nice fancy features. The core feature of the database is not really evolved, and it's 25 years old. So when we take a look on that one as well, is we're looking at an evolution of data over time, which we should not underestimate. So evolution of data means in our context that we have data which came out of a fixed field environment, and fixed field environments were actually not bad. I find it always funny when people come with that one because it was readable. You don't need to be an expert to understand this is a transfer from HSBC to Barclays, and you move some money around. Readable. Then came this. People moved in relational, and the relational structure made a lot of sense at the beginning. Disk space was expensive, CPU was expensive, and by using in a smart way these distributed patterns, it was really great, the relational concept. Nobody says anything different, and it still makes sense for some things today. But the complexity, when you see what people did out of that one, when you looked at an SAP empty platform, I was told is 140,000 tables before customization. The last system I touched was 100,000 tables. So it got even worse since then. This is not something which anybody with some sense can manage anymore. So that leads basically to the whole JSON concept. And when we take a look at JSON, look at the fixed field message, look at JSON. It's a formatted message. You're out of the fixed field, but it's readable. I'm dynamic, I'm flexible, I can do things great. But what happens now over this year really is this factor that people have JSON systems introduced. Payments was one of the big ones, but other things in retail as well, beyond processes, choose your poison, Covesa in the automotive industry. There's so many things. TM Forum, it's the telco guys, everybody goes JSON. And now people get at the point saying, hey, I have JSON data. I can turn on the dime. I can do funny stuff. I can enrich data in real time. I can drive value add to my JSON data without ripping apart my running system, which I so luckily introduced. This is where we're coming from the data side. But that is what I call the daily terror. The daily terror is that you have many databases, many apps, you have a lot of ETL, and I talk to folks who tell me that the worst also for 20 copies of data. And the statement was, we bring a new function. What is the first thing we do? Oh, we ETL to a new database. So when you have that one, single source of truth becomes really difficult, special engines, special pieces. And so far it looks nice, but this is a reality. You have tons of different products, and I didn't even start using different ETL products, different governance products, different whatever you have in there as well. You have a whole farm of things. And is this really, really smart? Do you want to reduce this? And interesting enough, when I talk to chief technology officers, one of the first things what they tell me is, I have too many database products. I need to reduce. So that is basically where we're coming to. And the big part about data as a product is now how we move of this chaos to the cloud. And nothing prevents you, by the way, today data as a product on premises as well. That said, the bigger part is normally that people try to say, I want to move to the cloud and really modernize. I want to have a non-monolithic microservice architecture. So we have a trinity of things, which I strongly believe are the three things that impact the de-siloing of data and the modernization of software. So data mesh and data domains are the core of systems. And data mesh and data domains are really the heart and soul of your new structures. MACH architecture is a fundament which delivers you data in a form from the architecture angle. So one is data representation and managing. But the most important part is at that point then, how you deal with people and with governance. When you talk to people and governance, the big question is, what does this mean? Governance can mean a lot of things. And depending who you talk to and which vendor, it becomes very convoluted or very simple, depending on what they're trying to achieve. My stand is, for me, governance means that I control who does what when, where's my data lineage, where my data come from, where are they going to, and I comply with GDPR and California CCP something. I never get that one straightened out. So this is pretty much the big question to ask and where things happening around. So when we take a look to those three things, let's go through them. MACH is the most easiest one. Nonetheless, I want to bring it up because there's a lot of misunderstanding. MACH stands for microservices, API first, cloud native, and headless. When we take a look to this one, and you talk to any architect who has still warm blood, says, oh yeah, everything I design is microservices based. And then you look into more detail, and these microservices, what they're looking into, are actually just kind of bolted onto some monoliths as APIs. And you see, no, but this is not a generic API. It's one specific functional service in one specific functional environment. And then I break my head out because a microservice needs to be a living organ. It needs to be driving some living functionality and is flexible to evolve. If this is bolted on into something which is basically static, you will not get suddenly flexible out of it. Due to the API first discussion is always very exciting. API first does not mean you have a header file in C. Let's be very, very historic here. No, API first means that the API design is in a way that it's consumable for others. So we're entering things, what type of APIs do we talk about? Can we use tools like Swagger? Can we use tools which allow us to emerge an API? Can we get that API versionized? Can we get the version independence for the user community? A real API first design and microservices are two different paths. Don't mix those up. An API, you can have a great microservice with a very static API, or you can have a great API, which is, by the way, not a microservice. So you want to have both items. And cloud native, that was when MACH was defined. We had a lot of discussion with various technical people in that one, and we agree by now it means anywhere. You need to be able to run your data in any concept, anywhere, anytime, which means multiple cloud providers at the same time, on premises at the same time, move data between these environments, and run from anything from a mobile device up to the biggest data center, up to the biggest data sets, actually. And the headless piece was something which generated for me a little bit a different discussion at the beginning, until I realized it's actually something when you look at smart microservices, and let's take a microservice which is designed for consumer management, customer management, client management. That microservice, if it's well designed, could be coming from e-commerce to telco to banks. Because the subject of managing a customer base information in all cases is actually, funny enough, the same purpose. You want to be able to provision a service where people can update their base information, birth date, social security numbers, addresses, whatever, as a service. So if you want to provide that one as a service to someone with value add functionalities, address verification and so on, you want to be independent. And that is really the value of headless as well. If you think about a company which is providing a service for credit cards, and they have different banks as their clients and different cards as their clients. And I'm dealing with one company which has 500 different banking cards as products on top. Yes, you need to have the abstraction of the front end, the back end, the processing, the issuing of cards, the validation that the card reach actually the consumer. All of those things are at the end the same, but you need to have the look and feel of the product of the end user. So the headless part is somewhat related to a good microservice and an API first design with the scalability of a cloud native system. So far, MACH, very important. Now, the fun part is I didn't came up with this one. This came actually out of an interesting group of people starting it out 2 years ago with 4 companies. And by now you will see it's a lot of companies, and there are nice certifications by now as well, which allows you to check if a vendor is actually applying those principles for real. By now, if you check out MACH Alliance, you see 60 plus members, 5 enablers, MongoDB is one of them. Why are we an enabler? Because we are not a solution. We are not provisioning MACH services and selling them to clients, but they're companies who do this very, very successful. And you want to make sure that a lot of these functions are actually indeed running on MongoDB. And that's the other funny part. A lot of these members using MongoDB. Oh, wonder. So much about MACH. There's tons of amazing white papers about it. It started out in retail. And when we look in retail, it's by now much, much more. I see a lot of consultancies, a lot of banking organization applying MACH. It really becomes standard concept, accepted concept, where before people talk about each of these items independently, the structure and more design thinking, templated thinking, validating your designs versus do you apply the right principles helped a lot for good design concepts. When we look now into data domains, which is the center of the data world and data mesh, I had to bring that subject in for you guys for one simple reason. There's so much discussion, what is a data mesh and what is a good data domain, that I could not resist to bring this one up. When we take a look at MongoDB and the original definition, yes, I read the Fowler blog, and yes, I read the book, and yes, I do not completely agree because it's completely driven on the analytical side, but leave that one out right now. That's another 2-hour discussion. If anybody would like to discuss this with me, I'm more than happy to deal with that. But when we take a look at the domain entities, and they defined an application plane, which MongoDB provides with Realm, GraphQL, our drivers into the multiple languages and the applications to that one. Biggest part obviously is our operational data plane. This is where people normally say, yep, I believe that, MongoDB, yep, on premises or in the cloud or self-managed, choose your poison, but it's all working. Then the stream processing plane is normally less concerning as well. People know, yes, MongoDB, change streams, Kafka connectors, Spark connectors, connecting to your Databricks for ML, all that stuff is legit and real and exists. More interesting it got when we look at the analytical data planes. And I started talking about Atlas Data Federation, Data Lake, how we're dealing with analytical data on large scale in the petabyte scale. Then it becomes more exciting and interesting. And when we then add the reporting to it, and I mentioned normally MongoSQL, which is our news baby connecting to things like Tableau and allows you SQL, real SQL into the federated system at unbelievable high speeds, or even our charts, which is our own little tool which allows you to visualize MongoDB data. So difference obviously is MongoSQL, you want to have multiple data sources, not only MongoDB, you have your external tools for that one, which bring multiple data sources together. Charts brings you multiple MongoDB data sources together, but if you have external data sources, it's probably not the right tool. Then we have obviously as well APIs like the data API and the drivers for that one. And if you suddenly look, oops, there are the 5 defined planes which exactly match. Funny enough, that picture, what we have inside our own developer data platform model. So at that time, the concept of data mesh and the concept of MongoDB's developer data platform, how we define it, actually fit very, very well. Now, the big discussion starts always at this point with, yeah, but this is only analytics. No, it is not. And this is the real part where it's getting exciting. What goes together, gets stored together, gets accessed together, gets processed together. That's a very old line from 2012 or so from MongoDB, before I was even a MongoDB employee, but I was a user at that time, so fair enough. So when we take a look to that part, the concept of data domains is that I bring data together in the original sort process. Remember my first slide, the evolution of data? This is back to the concept that I need readable, concise information. If I have something which belongs to a payment, I can store that payment together. I don't need to splash it over 150, 200 tables. I can have one payment document, for example, or other things. But the first thing what people then talk about with MongoDB is obviously operational OLTP. OLTP in the classical meaning, transaction processing, high speed, high volume transaction processing, asset compliant, which is regular listed up, globally distributed, all these things which are more modern and which are more fun, and 5.9/6.9's availability. That is stuff what today people want and what we are delivering and what most people are very, very happy using with. OLTP, search functions like our Atlas search function, mobile integration so that you have several 100,000 users of your bank and they want to look every month if their paycheck came in, and when it came in, they're looking happily. So how can we build this up? This is all real-time interfaces, OLTP, partially built out as online data stores, which is still one thing what people really love to do for good reason, getting out of the legacy. And then we have other domains like edge computing. When we look in the IoT space, we're working with the telcos on that one. How does edge then interface into data domains? Think about machine steering, construction, computer-aided design, and things like that. But that leads obviously to the first layer when we think again, MACH, hello, microservices. These microservices utilizing our unified data endpoints. They're using our APIs like the new data API. The data API is something what I can suggest people to try out. For me, it was amazing that I had, for example, for the automotive industry, we had a complete detailed data set in there. And they said, create me a data API. And the data API created the whole ontology based out of the data structure, created the API to that one, and had in 5 minutes, I had to try some things out. Probably today I can in less than 1 minute. I had the data API running, HTTP endpoint, completely self-sufficient, into the database following the complete ontology. So these are the things we can deliver. On the operational data side, you build your microservices out of that one. Microservices can access multiple data domains in some cases, but don't have to. And there are many APIs to do that. So that then you have the analytical plane inside the data domain. And this is a part where people get stuck. Because, wait, that means you're on the same data. Don't you have to do a normalized 3NF? Don't you have to bring the data over? Did not the data mesh talk about that I have a product owner who needs to bring my sources together? Yes, you need to do that. If you don't have a good data domain design, if you have good data domains in your bounded context already, then your problem to move to these distributed environments becomes much, much smaller. So why is MongoDB really so hot on that space? Because MongoDB natively allows you through the cluster concept to have your operational side of things, left side operational plane, operational data plane, the OLTP transaction, the cash register, the credit card payment, the e-commerce store, the transaction on your bank account, choose it, the real-time data. And then we have on the right side, additional data nodes, what we call normally the analytic nodes or workload isolation. A workload isolation is nothing more than a generic term. And one special use case of this one can be analytics on the same data set. Now, in MongoDB 6, we added up a lot of new features for that space, which makes things more exciting. One part is columnar indexing. This was a big thing what people ask for. I need to do the typical sum distinct over or count distinct credit cards over sum distinct by all payments or all transactions by credit card, and sort the credit cards after my top 100 consumers, something like that. So for that kind of function, a columnar indexing is unbelievably helpful and accelerates the queries by light years. That's the reason why data warehouses in classical sense are columnar these days. So starting out with my old own projects called DB2 Blue, 2010-ish. And today, when you want to look to things like Snowflake, stuff like that, those kind of systems, they are columnar based for good reasons, make sense in the analytical space. MongoDB has now columnar indexing too. We don't need to have columnar structures per se. That's a long discussion to have. But the key part is we have the columnar access into the elements inside of our documents, inside of our data domains. Then we have the data federation to connect large-scale historic data, which were historically in the data warehouse, normalized, and the big pile now can be coming out of the real data set, be stored as historical data set. Typical example, 10 years retention on data for sales receipts or transactions in banking, or choose whatever you want to do on that one. There's a lot of regulatory reasons and good technical reasons to keep several years of data. Now, do you want to keep those data in a hot database? Probably not. So we can data federate out. And then we have things like MongoDB SQL, which is great to access with your existing tools. So you don't need to restart your development there. And we have now asymmetric nodes as a new feature as well, which allows you to have really different configurations on these nodes for the analytical side or the analytical plane. Historically, it's a little bit like juggling. When you have an OLTP cluster, it's like juggling stones. You want to have equal, same size stones, and you juggle equally, very nicely from speed. And you don't want to have suddenly a big rock. Now, for the analytical space on the right side, we can have some really big rocks with different structures, different indexing, subject columnar indexing, all those kind of things we can do on the right side. We have columnar compression as well, which helps tremendously for obvious reasons, same reasons to have the same compression rates as you have with classical enterprise data warehouse legacy systems. And then we have cool functions like custom aggregations, which allows you user-defined functions and to do special things on those analytical data. All this together defines in our concept of the data domains an analytical data plane. Now, besides all those features, there's obviously the business layer. What's a typical thing we're doing? AI, ML, scoring is a big one. Then you want to have pipelines, rich data pipelines, enrichment. I mentioned, give me the information on how much spent is credit cards by over the last months, over the last 6 months, those kind of things you can build in right into the data planes, as well as how you scale out the system, how you can run your Jupyter notebooks, Spark connectors for things like Cloudera, or our partnership with Databricks. So there's a lot of cool stuff happening there on the analytical data plane, which allows you now to look on the data side, what we can do on the applications. Obviously, now you can have new applications written who are doing things right against the same data set, but with kind of asynchronous interfaces. Naturally, you can run on that data domain your native existing Tableau, Power BI, Looker, and I forgot 100,000 other products in that space. When we look at that one, the data lake analytics are becoming actually exactly the same thing without transforming the data. You can enrich data, back to my picture from the beginning. Enrichment is the hot stuff what people are doing, but you don't need to delete, or you need to do a 3NF for transformation. You stay native to your data. Then you have obviously microservices, which have API gateways, so you can do streaming things, you can do streaming ML, we can have endpoints connecting into these analytical data, or we can have actually complete new real-time applications done. So my most pet peeve project example is payments. I hope you guys don't mind. Payments is funny because it's very simple, to be honest. You have some merchant functions. A merchant wants to buy into a certain functionality and wants one of these terminals, or has 1,000 terminals. They need to be enabled. This is all part of the merchant domain. The merchant has all this information, and all good, activate their terminals and can manage some things and can manage users and contacts. So if something was broken, great. And they can build already out of that one. They can see how much swipes were done per terminal, how many terminals are in function, is something not working, whatever. They can analyze that one. And then we have the actual payments themselves, which are now linked to terminals which run actually these services. And obviously a terminal today is often virtual terminal. In many, many cases, there are no terminals anymore, but they're virtual. When I'm buying online a ticket, there's a virtual terminal. It's an API. It's an e-commerce interaction. But at the end, it works the same way like the terminal. And at that part, I have the actual payment transaction. So a merchant ID payment, it gets submitted into a system. I can do some real-time functions like fraud detection with feature space as just one example. There are many others. I can do a credit check maybe if I need to do. I do bigger things. Or then on the other side, that leads to points. So people get points for it, and I can do real-time ad bidding. So at this point, the consumer is buying something on my platform. So now I can offer to suppliers, hey, Boris bought new hair shampoo. I hope you get the joke. And now is anybody interested to advertise something else for him, like conditioner? So all of those things very much simplified, but this is happening today, and there's a good reason to do that one. And this is part of the flow, which can be integrated into one system. Remember, no data get copied here. We still have three major areas: points, you have the user, the consumer with his points and the latest transaction. All of that stuff is absolutely clean and is driven by microservices, is driven by the data domains, is driven by clear defined, well-defined API first design, is running anywhere in the cloud. You get the idea. This whole concept is a MACH concept. So when we take a look now to an example out of the retail space, this is commerce tools. They're using they have very specific single functions, and they can enrich sources, and they have functions like shop management and many, many other things going into MongoDB Atlas and offering specific microservices and building blocks to their consumers. So you don't even need to, you don't buy anymore commerce tools, the platform. You buy commerce tools by each category, what you like and what you need from them. And that is something where it's getting exciting. So I see a lot of clients. I saw some things at the TM forum. Some people shared some nice pictures, and you saw commerce tools for Verizon or AT&T, for example, in that context. Absolutely amazing product catalogs. You can realize these are things what these guys need. Or you have on the other side in parallel, real-time solutions for campaign engines, which are other vendors, other parties, other MACH solutions, which all lead to the right side, to the online clients or in-store functions as well. Not all e-commerce today is e-commerce. A lot of commerce is omni-channel. You buy something online, you bring it back to the store because the size is wrong, and the lady says, oh, you needed an S. Let me check. I have the M. You want to try it out and switch directly? Salvaging the sale, not just resend, but making sure the person gets the right size, gets the right product, happily out of the shop. That is value add. This is how data domains and MACH come together. But we haven't talked about the more interesting piece, which is people, governance, and polymorph data. So why does this matter? People, governance are who access the data, how are data used, who will get data in the future. And for that one, I have a little very simplified picture. Roles and responsibilities is always fun, but basically you need to treat your data domains, and this is why I'm totally agreeing with the definition of the data mesh, your data domains becoming products, data as a product. You're getting data originally I say for one reason, because over time, hopefully legacy systems will go away, and these publisher part becoming more like contributors in that meaning. But the product owner has to build a product idea. What does this product data domain delivers? When you talk about how does a product domain evolve out of something, the product owner needs to understand really the context of the design. They need to understand the life cycle of the data. What's happening? What is hot? What is getting into an archive? What can be in a data lake? How do I deliver the access to that one? I need to build really a vision and a roadmap how this domain is emerging. Because one big difference is you have to talk about an emerging, evolving environment. Suddenly, the same way like any other product is evolving, even version of how certain things are utilized. Maybe the use case was not really good, but then you want to go as well into the SLAs. Data coming in from publishers. You need to ensure these publishers comply to the standards they agreed upon, that the consumers on the subscriber side have actually guaranteed that certain things happen. And you need to be able to advertise new and coming data formats. So this advertising is not that the dude is putting something up at the bus stop, but probably which runs under data dictionary, ontologies. You need to be able to drive those. This is where our data API, for example, comes in very handy. So do you want to have Swagger APIs defined for that? There are multiple ways how this can be done. What you would like to avoid is that somebody who wants to subscribe, and I saw that one happening really, really bad, where people say, oh, I need to discover all data sources across our company. We have 50,000 databases. I need to discover these 50,000. And people go after those 50,000 data sources at their leisure. Are they even allowed to access this? Under what control points? Who's tracking it? Who got the guardians? Probably don't want to go there. So the concept of mature data domains are the prerequisite. You can discuss a data mesh in and out, but the prerequisite is that a data domain is moderated and is really managed, actively managed by an owner who understands where the data coming from, what is allowed to be done with this. Otherwise, you have very fast exposures. Now, on the other side, you have the publishers who have probably a deep, detailed domain expertise about certain parts of the data. Now, in this picture, I have one publisher because this is easier to paint. But the reality is a data domain is curated out of multiple sources published. That is why we have a product owner. Otherwise, the publisher becomes product owner in the end. And then we have the 50,000 database problem. No, you want to have a curated new layer where these data are stored, maybe even provisioned in different formats beyond the format what the publisher generates, because the product owner can do aggregations, they can say min values, max values, they can categorize consumers, they can have maybe dependency information, what the publisher doesn't have. So think about the bank. You have a core banking, retail banking, classical retail banking, account management. Then you have a mortgage department, which is an acquired company, third party, complete different data source. They don't even have the data and so on. Now, the product owner can try to sync those ones up, and based on given informations, which is hopefully a little bit more than the name, otherwise it goes really wrong. But there's as well a governance needs from the publisher. There's a relationship. What is a publisher happy to share? How do they share it? And under what SLAs? This is a force and back relationship on these different functions. On the other side, the subscribers have wishes. I want everything. I want certain parts. I don't want to deal with certain clearing. I don't want to do cleansing of data. I want to consume. That is why you call it a product owner. You have some production, manufacturing on one side, a consumer on the other side. And now if you call the middle then the data marketplace, the data exchange, whatever you call that, at the end it's data as a product. Data becoming made available out of multiple sources in a new context. New context, drive more value out of your data. That was one of my 4 big items. Check mark, done on that line as well. No more monoliths, MACH, we have done. You start to see we are really cleaning out the problems, what we defined, which prevent us to become a true digital enterprise. And when we take a look now on more practical parts, I went here through a very simple example. And after that one, we can discuss in more detail how this thing works. But assume we have a new company called Newco. That's a great company name. And they're storing addresses of their clients. And they have one client called Florida Power and Light. And yes, people ask me, is this address real? Yes, I got it from Google. So, and now this is fundamental client data. That's an address, that's public, but we want to make sure we clean up all our old client data, which come in from many, many, many independent sources. This is easy shareable. We can do schema validation. We can do strong data typing. So this is a really, really good document. Now I have a subsidiary, which is called TradeCo. TradeCo is shipping stuff around, and they have shipping information. They have shipping location for our company, Florida Power and Light, and they have a great address, which is not the same address as the corporate headquarters. Oh, wonder. I mean, who wants to get windmill shipped to your headquarters? Not really. 10 windmills getting worse. So you have a new address. So that's a private data set. Now, me as a product owner need to say, are other people interested in this one? Is this something which is private? Hey, TradeCo, how do you want to do? Oh, they said, yeah, we need those data in the client consumer context for our new apps and our new shipping information. And we need to put, by the way, the company home address onto this one for international compliance, but this is our shipping address. So you can say, okay, fine. We do a sub document for now called TradeCo. Whatever you guys need, you dump into TradeCo. And because you say, is it needs to be locked down? Is it public? No, it's public. Everybody can read it. It's all good. So you have those negotiations and TradeCo data are there. At that point, the TradeCo data would be discoverable over the data API because the data API would identify these new address information and then gets out. Now, I didn't do something smart here. I didn't say, wow, maybe I need a complete new substructure called addresses, which is maybe smarter than having TradeCo doing the subdocument, but that's level 1. Cool. I have additive changes. I always can expand and enrich data with new sources, new information. But I'm not damaging. This is the bad part, which happen often in RDBMS, where people say, oh, we do an RDBMS schema update. No, don't touch the table XYZ. I still need that for my old application. How much longer do you need this stupid column? How much longer do you need that stupid table? I've been through those discussions. Or that table is not maintained anymore by the source apps. What do you mean it's not maintained? So I've been through all of those discussions. For our concept of additive changes, we're adding that new record. We bring that record in a subdocument, but the record itself is accessible in the same way. So no changes are required to the original components code in that context. But now comes Payco, the money guys. The Payco guys have really interesting data, but they're maybe a little bit more difficult. They don't want to share those data because nobody needs to know what the amounts are and how much was paid for the new windmill. So, and the windmill was expensive. So they decided, oh, we encrypt this. So this is MongoDB client-side field level encryption, client-side, great. Option 1, Very simple. In this case, Payco has two subdocuments. One public, where they share the information. So if something goes wrong with payments, you want to go to Joe Mancini, but all the financial data are encrypted. You don't get it, or if you get it, you need to talk directly to Payco. Payco has a key and can enable you to do that one. So in this case, the product owner can work with Payco on brokering access to those data for very selected groups. But hey, people will still see there's a transact ID, amount, currency, and accounts payable is really interested in those data, and they can see them. So there's another option where Payco says nobody should see what we're doing, full stop. So Payco has a private subdocument. We encrypt the complete subdocument out. The end. Nobody can see it. So if people ask, hey, Payco, what do you have private? Not your business. It's money. Now the guys from account payable can still go to the Payco guys and say, dudes, can we talk? Do you have accidentally information about how much money? And we don't need to talk broadly about it, but we really need those payment data. So that's the option. So at that point, I have a selective governance, and I can build the governance down to every single element. I can actually build a governance down to every, with a key management system. Obviously, I don't do this manually, right? So bear with me, you have a key management platform somewhere on premises or in the cloud. And yes, there's many things behind HashiCorp as well. HashiCorp is great. I don't get today into all these options there. I can do as well as another layer, which I haven't talked about here, using obviously classical governance mechanisms. Collibra, Informatica, go on. All the things what people run in their companies. And I can use as well our regular LDAP functions, and I can use the MongoDB specific local functions as well. So I have a lot of ways to do very selective governance between subdocuments, between encrypted documents, field level encryption on client side. And this way I can build a structure as a product owner, which has a lot of information to one environment. I can curate data now and can decide, oh, but the trade code data, the address I want to lift out, and I start generating for everybody one big address structure, and I aggregate those out. And TradeCo has for a while still these data in, and they sit there, but on newer data, they go right straight through into the aggregation of the new address collection. So there's a lot of things which can be done, which are not damaging anything. So when we take a look now, we had the three items. We had the MACH architecture. We talked about what is done there, MongoDB's data API and other functions, which simplified really to build that architecture out. We talked now extensively on data mesh and data domains, which is really the center of the design, and naturally as well, people and governance and how this can be done in the smartest way. So at that point, we move over to the question answer section, and I have already one here, which I need to look into. 1 second. The question is, what of other data formats like Avro? With JSON, there's JSON schema, of course, but Avro permits better evolution story. Would you agree? Does MongoDB plan to offer it natively? We have actually a lot of clients using Avro data as input and using Avro data actually with JSON underlying structures. So I've seen this mostly in the retail space where people using Avro data in retail coming out of point of sale systems. So there's a lot of things around that one. I'm not sure what you mean by plan to offer it natively. Our internal structures are BISON, not JSON. So binary JSON with strong typing. So that is a given anyway. So we are way beyond the classical JSON, we do everything in text. So for that perspective, Avro can be very easily matched into MongoDB, import and exported. We support as well Avro files on the data lake side. So this is a question which comes regularly up. So if you have Avro sales receipts, for example, we can store this natively into the data lake, and the data lake sucks these files in and then makes them available. So there's a lot of interaction there. And that's how far I can go here right now. Otherwise, we can talk a lot about data formats. Oh yeah, while I'm advertising Avro formats for storing in data lake, we can do Parquet and other formats as well. That comes regularly up. So the next question is, what versions of MongoDB support this? Very simple. Most of the functionalities used here is coming out actually out of MongoDB 4.4 forward. So there's a lot of things happening around that one. But if you really want to have the whole end-to-end experience, I strongly naturally suggest version 6, which is our actual version. Actually, we're coming out with 6.1 already very soon. There is no secret sauce around that one to utilize the concepts that were deployed here, even if you have older versions. But if you look into some more modern things, like you would like to get time series data, for example, for ESG functions in real-time integrated with real-time computation on some values, then you need to go to version 6, or there are some functions which we added on that one, which are really helpful. The concept of the domain and the data API is available on Atlas today. So whatever you run on Atlas, the data API is a feature of that one, together with all the other governance components and detection mechanisms around that one as well. So that was that question. Anybody would like to? Okay, let me see if there's some native question. No, nobody raises a hand. I would see that one as well. So there's an anonymous question. Could you explain the analytical plane a bit further? Yes, so the analytical plane, think about it this way. It's when people think about analytics, they suddenly get into this, oh yeah, analytics, I need an enterprise data warehouse. And that is kind of these knee-jerk natural reactions. I need an enterprise data warehouse. But do you really need to have the representation of an EDW in today's world? Do you really need to have the representation physically into a normalized form to execute the same queries? That's an open question. My answer is, for a large number of queries you want to do in real time, which are for restricted data sets or smaller data sets, and some long-running queries where you're not necessarily time-bound, we can do this right on the data set. We can do this with the same functionalities of columnar indexing, columnar structure, compression, all the things what you want to do around that one. And we have a lot of people now using Tableau or the various other, I use always Tableau as the first one because I admit it, I use it myself. But there's tons of other tools out there which are all great, just to make sure I'm not putting anybody on the table. And any of these tools run against MongoSQL. And then you get really the effect that you have fast queries against Mongo data, which allow you to integrate things. Dito, the same is true that data, a typical question what I get is, I have my SAP BW. My HANA license is too expensive. And this is no bashing now. I don't mean this negative somewhere, but this is what people ask. And I want to merge in additional data from my manufacturing line, which is becoming very hard and difficult. Can I export data out of SAP HANA's BW and move them over to Mongo and merge them with manufacturing data and do something else with it? Yes. Standard interfaces, web methods as a great connector. What's the other one with T? Pull a blank right now, T something IO. If you need that, I can ping you afterwards. And you get the data out, you can get manufacturing, real-time data, maybe time series data meshed, enriched into your data domains, and then run directly real-time analysis of this one for manufacturing failures, failure rates, MTBFs, and things like that. So this is all integrated at the same time. So that's how far I can go right now, I think. So all these features are also available on MongoDB Atlas, somebody says. Yeah, obviously, Atlas is a superset of our developer data platform. So yes, all this is available on Atlas. This is not limited. It's actually, some things are available mostly on Atlas because our data lake is MongoDB Atlas Data Lake, for good reasons, called Atlas Data Lake. So I would like to support analytics and visualization without needing a data lake. Sure, you can do that. You don't need to have columnar capabilities. The question is, if you're switching off certain functions, and then you go back to MongoDB as an OLTP store without the analytical functions, and you run an analytical function, only OLTP data, it becomes a little bit restrictive. So at that point, you're like kind of a chicken egg. Then be prepared that somebody else, oh, why is the query not running well? I thought you have columnar indexing and columnar workloads, and you may run into a little bit some internal discussions there. just be prepared. But obviously, the capabilities of columnar and the columnar pieces do not have to do something with data lake. Data lake was about large amounts, storing data in our data lake, accessing those over data federation. The capabilities of the analytical plane and the capabilities about columnar functions, indexing, and so on, were all about data inside the same data source. So don't mix this one up. This is actually one area. That was a good question. How can I integrate lineage back to golden sources using MongoDB? This is one of the hottest things I have many discussions about, specifically in the ESG space or into treasury and risk data, where people by now asking for some standards. I think IFRS 9 is one of those. I need to lead back after I have some 5, 7, 8 levels of aggregation. I need to lean back to what was the source field, the source function. We do this very easy to annotating and enriching inside of the documents. So when you create a new document out of some existing raw data, you can keep actually the object IDs as additional annotation. And by doing this one, you can basically follow up the Ariadne path in both directions. You can either do it that you keep bidirectional or single directional, that's in the discussion, that the new documents get the information of the sources, or the sources get as well the information of the new document, or only the new document. So typical point is you run an aggregation over, I have all mortgages categorized into buckets of 1 to 100,000, $100,000 and $1 to $200,000. You get the idea. So in certain steps, so I get buckets, let's say 50 buckets at the end, and then I have one very big one at the top. And now I want to know what are the underlying mortgages to each of those buckets. This could be as well used for mortgage-backed securities, for example. And that's done very easily. You have then the list of the object IDs, which is not very big, inside of each of the documents stored. And you can follow through and saying, okay, go to a mortgage, single mortgage, and say, hey, show me where the final output in the following aggregates, and says, oh, this was used in the following aggregates, and you get the aggregate lists. Or you can vice versa saying, oh, I have the aggregate, and this part of the aggregate bucket, what were the underlying mortgages, and you get the list of the mortgages. Either way, this works very, very easy. It's a standard pattern. Any MongoDB solution architect can show you that one in more detail. It sounds maybe a little bit complex, but it's literally as part of the aggregation stage, you will add a component where you add, actually, you don't generate a new document, which you do probably as well as part of this example what I used, but as well as you use elements and standardized element IDs into that part, so that you have always the tracking part through the lineage of MongoDB. Dito, obviously, we do it very regularly, where data coming from into MongoDB. We had the discussion on the data as a product. Where is this data set coming from? So you saw my thing, what I did with TradeCo, and basically having certain subdocument structures based on companies. The same way can be done based on source, or again, you can keep, when certain data coming in get merged into, you can attach the source and the latest update, for example. That's one thing which is often done as well, that you say, okay, are the data up to date? So, and you want to check things if things work, and then you can look up on that line as well. So there's a lot of things there as well in that space. So I have more question. How can you easily manage data retention? I refer to data I have to discard after some time for legal compliance. Yes, this is an automation which is delivered by MongoDB. MongoDB has something, TTL indexing, where it's the same thing how you move data into retention, to be honest, out of the hot data set. So we have a lot of clients utilizing 3 layers for this one. One is they have the hot data, obviously, in the regular database. Then they have the next 3 months of data on an archive, and then all the historic stuff goes into the data lake. Automatically delivered, works very, very well, is very well integrated, and can do things together there. Hi, currently I'm using MySQL here. Currently we're using MySQL here. We was using views based on few tables, but here we're using strong JSON data. How can we fetch data from more than one table via a single query? Please correct me if I'm wrong. Okay, this is a design question. First thing is, yes. First, you can make lookups, joins in MongoDB as well. But when you're moving over and you have these kind of functions integrated, and these kind of functions, these integrated functions, using table data with JSON stashed in as normally as blobs and then get pulled out. This normally leads to more work than to revisit the format and saying, how many JSON documents do I actually need to fulfill the business function required on the application? In many cases, you end up actually with one single collection. I know this sounds arrogant, you don't need to, but the big part, the biggest mistake, what you can do is, and I did the same thing when I started the first time, admit it. Oh, I have 4,000 tables. Let's put up 4,000 collections and now make join over all the collections. And then this led not really helpful anywhere. So the right answer to do this one nice is to have the data structured in a way that they are optimized for JSON or for Bison, and get integrated in the form that is more optimized, and then you get the biggest value. And then honestly, if you have only a small number of tables and you stash JSON in there already, it's a very easy migration. It's not very hard. Again, we would probably set you up. I see only anonymous attendee. So, but if you have more questions, drop me an email. I connect you with one of our solution architects who can show you that one. We have something called a relational migrator, which is a small tool. We just click MySQL on the left side, and the thing is already helping you to build the data format. So it's a nice, nifty tool on that one. So there is more of a microservice architecture question. I have multiple user profiles that have a lot of data inside in it in a compute bucket pattern across multiple microservices. Is it better to merge this into one database or query across a different microservice using multi-data API endpoints? That is, it depends on the question. That's a trick question, not a bad one. But at that point, really, you have to look how the access patterns are. My point is normally when you have user profiles, and I've done user profiles with up to 2,000 different elements, if you can stash them into one, stash them into one. So typical example is people had the purchase history into one and check out, oh yeah, user profile, Boris has purchased last month, this month, all these kind of things, highest buying product, all those funny parts. Dump it all into one is normally easy and build one user profile microservice out of that one, which has a more comprehensive API. Now, there's obviously the other side where you say, well, this becomes a monolith, the data access becomes hard. Horses for courses, the right horse on the right racetrack. So that one, again, if you're interested in further discussions, I connect you with one of our solution architects to look into your specific case. But my personal path is always less is more. So one last question, because I'm over time and people have to go. How does MongoDB support the self-service aspect of the data mesh design? Support data democratization. That's a data API point. That's really why I was writing so much on data API. Data API, Swagger interfaces, people can do data discovery. You don't need to program anything. You have direct access to what the data as a product owner is provisioning for you into this design. And that's a level of democratization. Now, democratization means as well that you still have controls, governance, and the things what I talked about. It's not everybody gets everything, but everybody gets everything which they're allowed to see, to be very, very clear. So this can be very easily managed over key management or key functions. Cool. That was a lot of questions. I answered 17. That's pretty cool. And at that point, again, there's my email, there's my LinkedIn if you want to friend me, and I appreciate everybody participating. Thank you so much, folks. Have a good day. Bye-bye.